Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 10, Branch Prediction. Why are we doing branch prediction? Well, branch prediction or performance via prediction is one of the 8 great ideas of computer architecture by David Patterson and John Hennessy discussed in their textbook, Computer Organization, the Hardware-Software Interface. Now, in a pipeline machine or processor that you are developing in this course, which is a 5-stage processor, if you have a control hazard and have to change the flow of the instructions in the pipeline, there could be instructions in a pipeline stage that should not be implemented or executed because of the process or the flow of the program has changed. So you have to actually cancel those instructions, no bubble, flush, basically invalidate those instructions. Now, if you think of it, if I have to invalidate an instruction in a pipeline stage, I'm net effectively reducing the performance of my computer because for that one clock stage, the instruction in a particular stage is doing no work. So let's see what it would look like in a 5-stage pipeline diagram. So now taking a look at the 5-stage pipeline, in the memory stage, you were making the decision whether to branch or jump due to a control hazard. And if you had to change the flow of the processor because of the jump or the branch, you actually had to invalidate the instructions in the decode and the execute stage because those instructions should not have occurred because the stream of instruction has changed due to the control hazard. Now, we have enough time in our design where we can actually determine whether we have to have this branch or jump, change the address in the iFetch stage so we are still pulling out the correct instruction. Therefore, we do not have to invalidate the instruction in the iFetch stage. Now, the goal of branch prediction is if we have a high enough accuracy, we're going to remove the need to have all those no-ops in the decode and execute stage. Once again, the goal of branch prediction is if we have a high enough degree of correct prediction, we can actually improve the performance of the processor or of your design. And you will be actually implementing branch prediction and validating that in this assignment. Now, all branch predictions basically have a basic process or set of things that you have to do. Now, for a 5-stage, in the decode stage, you are going to, 1, have a simple branch prediction algorithm to determine whether I'm going to predict yes or no. I'm going to calculate the address that I should branch to if a branch would occur. And then the third thing is if the branch prediction is true, I'm going to send a signal to the iFetch stage and say, please change the program flow to the calculated branch prediction address. Now, when we go into the instruction or the execute stage, we still need to calculate a target address, but it's going to be a different target address. It's going to be the target address of a recovery. So if I had a branch prediction and I failed, the prediction ended up being found to be false, my recovery address is the actual instruction immediately following the branch or jump instruction. Now, so the recovery address is going to be the PC address of the branch plus the number of bytes to equal the instruction, to point to the instruction immediately after of the branch. So we can actually do that in the execute stage, even though we don't know whether a prediction is true or false. At the same time, in the ALU from assignment 7, you are determining whether the branch condition was true or false. Now, when we move into the memory stage, you're going to take the value that was calculated from the ALU, the conditional test for the branch, and if you find out that your prediction was false, you will then be notifying the iFetch stage to use the recovery address to recover from an incorrect prediction. So those are the basic instruction flows that all branch prediction has to follow, and you'll be implementing these in this assignment. Now let's switch over to Codasip Studio so I can show you a little bit what you will be doing. You will be uploading 2 new programs to actually test and use in the branch prediction assignment. The first one is prediction underscore test. It's an assembly routine that you will use to help validate that you've actually implemented the search tree correctly. It's broken into two tests. This first test up here is testing whether a jump prediction has been implemented correctly. If you think about it, a jump is an unconditional change of control flow. It will always occur, so you know that 100% of the time your prediction will be correct. So the nice thing about this, you can actually implement the first part of the branch prediction circuitry without needing to do the recovery. So it's a good way of doing a little increment towards the final assignment and validate that. If you see in the comments, there are two comments for the different line numbers. For example, line 37, I have prediction equals 6 cycles, if no prediction equals 8 cycles. What that is telling you, if you step through this and you don't have branch prediction implemented or jump prediction, it should the cycle count at this stage will be 8. And once you've successfully implemented jump prediction, it will be cycle 6. So this will be used to help validate that your jump instruction or jump prediction is occurring correctly. Now, if we come down to the second half of the assignment down here, it is a branch prediction test. It will now validate two things: whether your prediction algorithm is correct, and that two is whether your algorithm is correct and that your branch prediction, you're branching to the new address, but also whether you're recovering on a failed branch. So this test will help validate whether your circuitry is working correctly. Now we have another test called bubble sort, which if you look at this set of instructions down here, there are 2 for loops. There's going to be a lot of branching. And so this will be a good case to show you that your branch prediction is actually providing the benefit that you desire. Now, one other piece of software that you'll learn, or another piece of the tool, is called the profiler. Now, if I switch to the workflow perspective, under bubble sort, you're going to be running what's called a profiler. And the result of the profiler is going to be a set of, or piece of information that is statistics about the program. And so if we take a look at this program that I ran, and I ran it with a different data set than you will have in your assignment, so these numbers should be different than yours, you can see that it took my program here over 4 million cycles to execute. Now, if I go down to the demo, or excuse me, if I switch over to the resource coverage and I scroll down, these clears are when I'm clearing or putting a no-up bubble in my pipeline register. So this is showing right now that I have over 400,000 no-up bubbles that I inserted in my decode stage, and also 400,000 plus in my execute stage. So the goal of this assignment is that after I do branch prediction, that those numbers will be going down. And you'll be seeing that as you progress through the course. Good luck.